Good morning, children. We discussed about what are the types of separation of mixtures. Okay, heterogeneous mixtures and homogeneous mixtures. How to separate the um, mixtures. Uh, we followed some um, methods: sublimation, centrifugation, solvent extraction, distillation, fractional distillation, and chromatography method. Okay, listen. In heterogeneous method, we used sublimation and centrifugation method. Okay, then we have homogeneous distillation, fractional distillation, and chromatography method. Okay, so I finished solvent extraction and fractional distillation method. Then the next method is, listen, fractional distillation method. Listen, to separate two or more miscible liquids. Miscible liquids means they are containing many types of um, compound in that liquids. Okay, which do not differ much in their boiling. Okay, boiling points. Okay, the boiling points, only we use the boiling points and separate the mixtures. Okay, difference in boiling points in less than 25 Kelvin. We are using the three types of thermometers, no, Kelvin, Fahrenheit, and Celsius. So here we use Kelvin. Okay, fractional distillation is employed. The boiling points only used the fractional distillation methods. Okay, in liquids. Fractional distillation is used to petrochemical industry. How to separate the petrochemical in industry? They are using the boiling points of liquids. They are first they are distracted crude oil. Then they are using the boiling points and separate the many useful things. Okay, you study 8th standard. What are the petroleum products? Diesel, petrol, LPG, kerosene. These are the things separate to crude oil. Okay, so that is called petrochemical industries. Okay, to obtain different fraction of petroleum, to separate the different gases from air to distill alcohols, etc. Okay, here see the fractional distillation method. The alcohol and water. First you take here alcohol and water. This column is called fractionating column. You want use one thermometer and water outlet. Cold water means cool water, and alcohol. Okay, to separate water and alcohol. Okay, if you heat this mixture, the alcohol is evaporated. The alcohol is evaporated, the fractionating column, and the gas is come from this um, tube. Okay, this tube come from this tube. Then the gas is cooled here. Then the gas is cooled means the liquid is formed. Okay, so the liquid is alcohol. The alcohol is conserved here. Okay, this flask. Okay, this method is called distillation, fractional distillation method. Fractional distillation method. In this method the boiling points only used. Okay. Okay, next one, chromatography method. Chromatography method. Before we will discuss the technique, we will take a look at the difference between the two important terms. Okay, adsorption and absorption. Absorption and adsorption. Adsorption is the process in which the particles of a substance is concentrated at the surface of another substance. Adsorption means the substance is concentrated only at the surface of another substance. Okay, this is called adsorption. Adsorption. Okay, then what is meant by adsorption? Absorption. First one adsorption and next one absorption. Absorption is the process in which the substance, here particles, listen, adsorption means the particles of a substance. Here the substance only, the substance is uniformly distributed. Here concentrated, here uniformly distributed throughout the bulk of another substance. Uniformly distributed the bulk of another substance. Here only at the surface. Okay, here only at the surface. Adsorption means the particles are concentrated only at the surface, another substance of the surface. Here the substance is uniformly distributed. Okay, the uniformly distributed bulk amount of substance is uniformly distributed another substance, another substance. Okay, this is called adsorption and absorption. Okay, then for example, here see the example. For example, when a chalk stick is dipped in ink. Okay, adsorption and absorption. Okay, example. Okay, listen ma. When a chalk, you know the chalk, white color chalk. Okay, is chalk stick is dipped with ink. What is the color of ink? Red ink and blue ink. Okay, if you dip the chalk stick in a blue ink, the surface remains the color of the ink due to adsorption. So the chalk is absorb the colored molecules. Okay, while the solvent of the ink goes deeper into the stick due to absorption. Okay, that is called absorption. So first one, when a chalk stick is dipped into ink, the surface retains the color of the ink due to adsorption. That is called colored molecules. Okay, then the solvent of the ink goes to deeper into the stick due to absorption. Okay, so hence on breaking the chalk stick, it is found to be white from inside. Is there no? Yes. So chromatography is also a separation technique. It is a separation technique. Okay, it is used to separate different components of a mixture based on their different solubilities. Okay, in the solvent, solubilities in the solvent. Okay, there are several types of chromatography. So you understand the chromatography method, we are using two methods, adsorption and absorption. Okay, adsorption and absorption. Okay, here have several methods of chromatography. Listen, this is ink pot. Here have water. Listen, this is a ink pot. Here have water. You dip this paper. You dip this paper in the water. You dip this paper in the water. So the water color is changed. Yes or no? Here have blue ink means you dip the paper in the water color is changed, blue color. Okay, then listen, next one, you listen this. So the ink. Okay, here see the colors. Okay, here see the colors. No, end and ink. Okay, end and ink. Okay, this is called paper chromatography. Okay, listen. We can see that in the case of sugar we get a clear solution and the particles never settle down. Okay, listen ma, next one, listen, this is a chromatography method. Listen, sorry, here see the paper chromatography based on the principle of the simplest type is paper chromatography. Okay, so paper chromatography, what is maybe paper chromatography? In this method used to separate the different color dyes. Okay, different color dyes in a sample of ink. Okay, a spot of the ink, example black ink, is put on the piece of chromatography paper. So you put the, first you take it on chromatography paper, you put the ink, black ink on that paper. Okay, this paper is taken set a suitable solvent. So solvent means water and any alcohols. Okay, so you take that solvent as shown in the figure. Here see the figure, no, here see the figure, no, this figure. Okay, this is the figure. Okay, this figure. Listen. So this paper is a suitable solvent as shown in the figure. The black ink separates into its constituent dyes. So the color is changed. The black ink separates into constituent dyes. As the solvent moves up the paper, the dyes are carried with it and begin to separate. They separate because they have different solubility in the solvent. Okay. The paper chromatography is based on the solubility of the solvent only. Okay, they separate because they have different solubility in the solvent and are adsorbed to different extraction by the chromatography paper. The chromatogram shows that the black ink contains 3 dyes. Okay, the black ink contains 3 dyes. Here see the 3 dyes. Okay, this is in black ink. Here have the 3 dyes. No, this one, this one, this one. Okay, 3 dyes. Okay, listen. So that is called paper chromatography. So okay, next listen, solution. Next one, solution. Okay, a solution is a homogeneous mixture. It is a homogeneous mixtures of 2 or more substances. Okay, in a solution, the component present in lesser amount by weight is called solute. The component is less in weight, that is called solute. And the component present in larger amount, that is called solvent. It is called solvent. In a short solution, a solution can be represented at the follows. Solute plus solvent gives solution. For example, the solute is salt. Okay, the solute is salt, NaCl. Okay, the solvent is water, H2O. Okay, the NaCl is dissolved in water. That water is called salt solution. Salt solution. Okay, then types of solutions. Types of solution. Based on the particle size of the solute, the solution is divided into 3 types. What are the types? Listen, true solution, colloidal solution and suspension solution. Okay, listen, here have one activity. You see this activity. Take bottles. You take one bottles containing sugar. Okay, you take one bottle, you add the sugar, starch and wheat flour. What is wheat flour? Wheat flour means kodumai maavu irukla adu. Okay, so take bottles containing sugar, starch and wheat flour. Add 1 teaspoon of each to a glass of water and stir well. Okay, so first you take one bottle, then you add 1 spoon of each means sugar 1 spoon, starch 1 spoon and wheat 1 spoon. Okay, you add it and then you stir that solution. Leave it aside for about 10 minutes. You don't disturb 10 minutes. Okay, what do you observe? Which one will mix? Is the uh, sugar and water only mixed. Okay, sugar here not have water, so the bottles containing sugar, starch. Okay, the sugar and starch mixed and wheat is float on the solution. Okay, you do this experiment in your home. Okay, listen. Then we can see in the case sugar we get clear solution and the particles never settle down. Okay, if you take the water and you add sugar in that water, so sugar is a solute, water is a solvent. Okay, you add sugar into water, the solution will be clear. Okay, never settle down, precipitate. Okay, this mixture is called true solution. True solution. Okay, in this case, starch and water, we get a cloudy mixture. Cloudy mixture. This mixture is called colloidal solution. Colloidal solution. Colloidal means you see ice cream, and ice cream and some colloidal uh, colloidal substances. You see that is colloidal substances. Okay, that is called um, cloudy mixtures. This is called colloidal solution. In the case of wheat flour, is mixed with water. If you take water and mixed with wheat flour, uh, we get a very turbid mixture and fine particles slowly settle down at the bottom. Okay, the um, powder is settled down the bottle. Okay, sometime. Okay, this mixture is called suspension. Okay, listen. First one, types of solution. First one, true solution, water plus salt. They are not have any precipitate. They are clear solution, that is called true solution. Clear solution is called true solution. Then you take water plus starch. The mixture is colloidal solution, that is called colloidal solution. Then you take it water and wheat powder, you add it and stir. The wheat powder is settled down the bottle. The solution is up the bottle. So that is called suspension solution. Okay, so the types of solution. What are the types of solution? True solution, colloidal solution and suspension solution. Okay, what are the difference among the true solution, colloidal and suspension? The major difference in the particle size of the solute. Particle of the solute. In fact, interconvenience, these mixtures are possible by varying the particle size of certain chemical and physical methods. Okay, listen, see this picture. Particle size less than 10 power minus 7 centimeter. 10 power minus 7 centimeter, that is called true solution. Okay, the particle size, the solution is divided into based on the particle size. Okay, first one, true solution, the particle size is less than 10 power 7 centimeter, 10 power minus 7 centimeter. Then colloidal solution, particle size between 10 power minus 7 centimeter and 10 power minus 5 centimeter. Okay, here true solution means less than, listen, less than 10 power minus 7. Here between 10 power minus centimeter and 10 power 5 centimeter. Then suspension solution, particle size greater than 10 power minus 4 centimeter. Okay, these are important. One more question ma, you read this thoroughly. Okay, the particle size of the true solution, colloidal solution and suspension solution. Okay, listen. Next, colloidal solution. Colloidal solution. A colloidal solution is a heterogeneous system. It is a heterogeneous system consisting of the dispersed phase and the dispersion medium. Dispersed phase or dispersion medium can be a solid or liquid or gas. There are 8, listen, there are 8 different combination of possible. The combination of gas is not possible because gas in gas always form a true solution. Gas in gas always form a true solution. Okay, listen, here have the tabular column. You see this tabular column. If you take it solid and solid, solute means solute, yes, solute means for example solute sugar, okay, solvent, water, okay, already we discussed, okay. Listen here solid, solute is a solid, okay, solute is a solid. Here solvent also solid, okay. Solute is a solid and solvent also solid. So name is salt salt means solid solution. For example, alloys, gems, colored glass. Okay, these are solid in solid. Okay, solid also solid, solvent also solid. Okay, then next one, solid liquid solution, paint, inks, egg white, okay. Then solid gas, um, aerosol, smoke, dust, liquid, solid, gel, curd, cheese, jelly, liquid, emulsion, milk, butter, oil in water, liquid gas, aerosol, mixed, fog, clouds. Then liquid gas, gas, solid formation, cake, bread, okay. Gas, liquid, foam, soap, leather, aerated water. So here give the tabular column, solute, solvent and the name and examples. Okay, you read this one. Okay, here have the difference between the types of solutions: colloidal, suspension, true. Okay, suspension, colloidal solutions. Okay, you see this tabular column: particle size, filtration, separation, settle of the particles, settle on next appearance, scattering of light, then diffusion of particles, Brownian movement, nature. Okay, these are the properties, difference between the types of solution: suspension, colloidal and solutions. Okay, suspension, colloidal solution, suspension, colloidal solution. First one, particle size 100 nm and 1 to 100 nm and less than 1 nm, nanometer. Okay, nanometer, nm means nanometer. Filtration, possible, impossible, impossible. Okay, here see first one, suspension, colloidal 100, suspension, colloidal, true solution. Okay, three types of solution: suspension, colloidals, true solution. Okay, you see first one, greater than 100 nanometer, here 1 to 100 nanometer and less than 1 nanometer. The filtration method is possible for suspension solution, colloidal solution and colloidal solution is not possible, true solution possible, impossible. Okay, so only possible for filtration method, suspension solution only. Okay, then filtration, separation, possible, impossible and impossible. Then setting of particles, settle on their own, settle on their centrifugation, do not settle. Okay, true solution is a clear solution. Appearance, opaque, translucent, semi transparent. Okay, transparent. The scattering of light, does not penetrate, scatters, does not scatter. Diffusion of particles, do not diffuse, diffuse slowly, diffuse rapidly. Brownian movement, may show, shows, does not show. Okay, so nature, heterogeneous, heterogeneous. Then true solution is a homogeneous mixture. Okay, okay, listen. Next, listen ma. Brownian movement, Brownian movement, listen. When colloidal solution viewed under the powerful microscope, you take it colloidal solution under, you see the colloidal solution powerful microscope, it can be seen the colloidal particles are moving constantly and rapidly in zigzag direction. The colloidal solution is constantly moved in a zigzag direction. That movement is called Brownian movement. Listen, this is one 2 mark question, I think. 2 mark question or 5 mark question. Okay, listen. What is meant by Brownian movement? You take it colloidal solution and view under the powerful microscope. The colloidal solution have particles. No, that particles move constantly, rapidly in a zigzag direction. That is called Brownian movement. Here see the direction. Okay, zigzag direction. Here, son, zigzag direction means this zigzag direction. This direction is called zigzag direction. This movement is called Brownian movement. Okay, then Tintal effect. Tintal means 1869 observed that when a strong beam of light focused on a colloidal solution. So Tintal effect means the light rays is passed to the colloidal solution. The path of the beam becomes visible. You see the path of the visible light in a colloidal solution. This is called Tintal effect. This is called Tintal effect. Okay, that path is called Tintal cone. This phenomenon is not observed true solution. Okay, only colloidal solution. Listen ma, you take it colloidal solution, you observed powerful microscope, the particles of the colloidal solution is moving constantly in a zigzag direction. That is called Brownian movement. Okay, then Tintal effect means you take it colloidal solution, you pass the strong light, okay, in a colloidal solution. You see the path of the light visible. That is called Tintal effect. Okay, these two effect is very important. Okay, so more to know, the beam of light coming from headlights of vehicles is due to Tintal effect. Tintal effect. The beam of light coming from headlights of vehicles. You see the headlights of vehicles. Okay, that light is Tintal effect. Blue color of sky is also due to Tintal effect. Okay. Okay, listen. Test yourself. Why whole milk is white? Why ocean is blue? Why sun looks yellow when it is really not? Okay, you test yourself. Okay, listen. Then emulsions, a special kind of colloids. Emulsion is a special kind of colloids. Listen, an emulsion is a colloid of two or more immiscible liquids where one liquid is dispersed in another liquid. This means one type of liquid particles get scattered in another liquid. In other words, an emulsion is a special type of mixture made by combining two liquids that normally do not mix. Okay, what is meant by emulsion? The two types of liquids combining, that liquid is not mixed, that is called emulsion. The word emulsion comes from the Latin word meaning to milk. Milk is one example of emulsion of fat and water. Is or no? The milk is containing fat and water. So that is not combining, that is separate. Okay, the process of turning of a liquid mix into a emulsion is called emulsification. Milk, butter, cream, egg yolk, paints, cough syrup, facial creams, pesticides, etc. These are emulsions. Okay, these are emulsions. Types of emulsions. Listen, the two liquids mixed can from different types of emulsion. For example, oil and water can from an oil and water emulsion. Example, cream. Okay, when the oil droplets are dispersed in water, or they can form of a water in oil emulsion. Example, butter. with water disposed in oil. Types of emulsion. Listen. See the emulsions. Okay. Types of emulsion. Okay. Okay. These are the types of emulsion. Okay. Next you see emulsion find wide applications in food processing, pharmaceutical, metallurgy and many other important industries. They are using the emulsion method. Have you seen colorful patches on a wet road? You see, when oil droplets is water in road, it floats over water and forms a colorful film. Find out why. The scattering of light, the different types of liquids are mixed in the road. Okay, you see that answer. Okay, listen. In this lesson we are discussing about, depending upon the chemical composition, matter is classified into elements, compounds and mixtures. And elements, compounds considered to pure substance, they contain only kind of particles, whereas mixtures contain more than one type of particles and they are considered as impure substances. A homogeneous mixtures, the components are uniformly mixed and it will have single phase. Heterogeneous mixtures cannot mixed with roll out uniformly or uniformly and it will have a more than single phase. Based on size of the solute particle, heterogeneous mixtures can be classified into as colloidal solution and suspension solution. Okay, these are the things we remembered. Okay, glossary. Listen. First one, elements. Element is a simple substance, atom, single atom. A substance composed atom having an identical number proton in each nucleus. Compound, two or more elements combined to give a compound. And mixture, two or more components to give components and mixed with to give a mixture. Then solution, homogeneous and heterogeneous solution, colloid, suspension, emulsion, absorption, adsorption, centrifugation. Okay, so these are glossary. You see this glossary. Okay, listen. 5 more question. Write the difference between compound elements and compounds. Already you read. Now explain Dintal effect and Brownian movement with the suitable diagram. Okay, listen. Now I will teach it. Thought no. Listen. These two method, Brownian movement. Listen. This is a second 5 mark for your book back question. Brownian movement. Okay, then Dintal effect. You write this paragraph and this diagram, then Dintal effect you read this. Okay, so this one 5 mark question, you read it. Okay, thank you children. This lesson over. This is a quarterly portion for your class. You read thoroughly. Okay, thank you children. If you have any doubt, you ask me. Okay, thank you.